absolute value equation. And then we're going to start the 1.7 notes, which are about solving linear inequalities. Okay, and I think we will probably have to do the absolute value inequalities next time. Okay, so we're going to take a look at this. I'm just going to hit this. Oh, you're here. You didn't do the PSAT?
No.
No. Okay. All right. Just gonna distribute these. The people aren't here, and then we will. Okay. All right. All right, so we're gonna do these, we're gonna do the warm up together. Let's see if I can find it. Okay, here we go. All right, so this first one is a basic quadratic equation, right? And I want to solve by factoring, okay? So who can factor that for us? Okay, Logan.
+3 and negative, or yeah, +3 and negative 2.
Good, so how would this factor?
X plus 3 times x minus 2.
X plus 3 times
Yeah,
x, opposite, yeah, x minus 3, x plus 2 equals 0. We'll get different 10, I don't like that one. Okay, and then by the zero product property, we'd say
3 negative 2.
x minus 3 equals 0, or x plus 2 equals 0, so x is
3 or negative
3 or x is negative 2, right? That's how we solve basic quadratic equation. Okay, so what if we go to number 2? Okay, number 2 says apple squared minus apple minus 6 equals 0. How does that compare to this previous problem? If I can get it on the same screen.
the same thing.
It's the same thing, right? This is the same thing. Doesn't matter if it's apple or x. No, right? So Daniel, what are the solutions to this?
It'll be apple. Oh, right, apple. Okay,
Yeah.
Apple equals 3 and negative 2.
Or negative 2, same thing, whether it's apple or it's x,
Did you
right?
write apple equals 3 comma negative 2?
Yeah, either way. Yeah, 3 comma negative 2. Okay, so the idea here is regardless of what we have here, if I have something squared minus something minus 6 or whatever constant we want, right? When I have this particular pattern, I can solve this in the same way, right? Regardless of what that something is, right? So if we have this pattern, something squared and something, right? This is the case where we can do U-substitution. Okay, which is what we said last class, just trying to review that, right? That's what we're looking for, is the pattern where we got something squared and then something, and we can have different constants here in front of them. Okay, so let's take a look at number 3. Okay, I have y to the 6 minus y cubed minus 6 equals 0. Adi, what do you see?
So I see that 3 is half of 6, so we can use U substitution here.
Good, right? We have this pattern. So let u equal what?
Let U equal y to the 3rd.
Great, right? Because this guy squared, y cubed squared equals y to the
And
6.
then
Okay,
let U squared equal y to the 6.
good. And now we're ready to make those u substitutions. So what does this become?
U squared minus U minus 6 equals 0.
U squared minus u minus 6 equals
And then
0.
it's the same thing we had before.
The same thing we did before. Yeah, so factor that for us. Adi.
U minus 3 and U plus 3. I mean plus 2,
U
sorry.
plus 2,
Is equal to
good.
0, so U is equal to 3 or negative 2.
Good, u equals 3 or negative 2. But we weren't really interested in this variable that we introduced, which was u. We're really interested in the variable y.
So 3 is equal to y squared.
Oh, y cubed, right?
Y cubed, sorry. And negative 2.
Good, and then we solve each one of these cubic equations, right? How do we solve them?
Take the cube root.
Take the cube root. Good, so I'm gonna take the cube root both sides. And then I get y is equal to the cube root of 3 or the cube root of negative 2. And that's okay because it's a cube root. I would take a cube root of a negative number. If it were an even root,
Then you usually take I out.
then we do with this stuff with that. Okay, so those are our two values. Okay, so people, do you feel comfortable with the U substitution,
I like
what
it.
we're looking for and how it works?
Yeah.
Okay, right, so it's just method to try to do something with quadratic type. Does it make sense? Okay, excellent. Okay, so we're gonna flip back to the notes on 1.6. Okay, and we're gonna continue on to, if I can find them.
7.
Okay, so we're going to do example 7. Okay, so I sent you the video of example 6, in which I showed that if we check the solution 3, it's actually going to work, or you could walk through it more slowly if you needed to. Logan.
Is there a quiz on Friday on 1-4 and 1-5 or 1-5 and 1-6?
1-4 and 1-5. So 1-6 is not on the quiz. Okay, just what we did with solving quadratic equations and complex numbers. Yeah, Izzy.
What do you recommend to do?
To study for that, I don't have a guide, but I would go through the notes. You could rework some of those examples. There's also practice problems in the notes in both 1.4 and 1.5. We did some of the 1.4 in class. I know people didn't finish it. We didn't do the ones from 1.5. I think we just did one. So you could do those, or you could look at your homework and see problems that you thought were difficult on the homework before. Try those now. Okay, that's just 2 sections. All right, so the next one we want to solve is x plus 3 to the 3/2 is equal to 8, okay? So this is kind of similar, I'm gonna write it over here so I have room. So if we had like a square root, right? If we had a square root, we'd square both sides. Last time we had something cubed, so we took the cube root. So I want to generalize that. I want to undo something to the 3/2 power. Right?
You put it
So-
to the 2/3 power.
I could put it to the 2/3 power. Okay, let's see if Daniel's suggestion will work for us. Okay, so he's suggesting that we raise this to the reciprocal power, both sides. Okay, why is that a good suggestion?
Because it gets rid of the exponent.
Yeah, it undoes it, right? So if I have 3/2, something to the 3/2 power, and I raise that to the 2/3, 3/2 times 2/3 becomes 1. Okay, so we want to raise both sides to the reciprocal power, which is what we were doing when we take a square root of something squared. We're raising it was to the 2nd power, we raise it to the 1/2. Okay, so what happens here? This becomes
X plus 3
equals 8
equals
to the
4.
2/3. So then we have to figure out how do I simplify 8 to the 2/3? Ari, what do I do?
You can change 8 to 2 to the 3rd, and then you can cross out.
Oh, I like that. That's clever. So Ari is saying 8 is actually 2 to the 3rd to the 2/3. So this is, I want to show how to do this more than one way. I like this.
That's not how I was gonna do it.
So yeah, that's not how I was going to do it, but I like it. So let's show it. So then the 3's cancel out and this just becomes 2 squared, which is 4. Or this is the more traditional way. The other way to think about 8 to the 2/3 is to take the cube root of 8 and then square it.
4.
That's not what I was gonna do.
That's not what you were going to do either.
No.
So that's another way. So this becomes 2 squared. How are you going to do it?
I was gonna rewrite it as 8 squared to the cube root. So
Oh, you could do that
64
too.
So
You
it
could
would be
do that
64
too.
to the cube root, which is still 4.
You could do this as the cube root of 8 squared, which is
64.
the cube root of 64, which is 4. Okay, 3 different ways all get us to 4. Whichever way makes sense to you. These are all perfectly valid. Okay, this is the most traditional way.
Mhm.
The one in the middle, but the other 2 ways are
Can
great.
you do that like for any like fraction exponent, like if it's
Yes,
to the 2 to the 4th, you could take the 4th
Yes.
root of it and
You-
multiply it by 2.
2 to the 4th,
Like it was 8 2 to the 4th.
8.
Well, no, because
the
8
2
is in
over
the
4.
4th root. So it would
So
be-
that won't work so well.
So what would you do? then?
Well, if it were 2, I mean, this is probably not going to simple. This is going to become what
It's about
the 4th root of 64, and so then I could take out a 2, because
yeah.
2 to the 4th is 16. So this would be
And-
16 times 4, so this would be 2 times the 4th root of 4.
In this case, did you square it because the numerator is 2, or is that just what you always do?
Did I
Like
square it?
when you did 8 2 3 and then took the 2 roots squared.
Well, no, it's because that's the 2 to the 3rd. The numerator is what the, with
This-
the
No, I'm
power
saying
is
is,
and the
I'm
root.
saying
This-
is, did you square it because 2 is the numerator? Like,
Yes,
it was
yes,
like
yes.
five.
This becomes the, I can't get a different color. This cube root, that becomes the index and then the numerator becomes the
Okay.
power. Okay, all right, so now we're down here. So now we have 3 different ways. Now we figured out that 8 to the 2/3 is 4. So now we have x plus 3 equals 4, whichever way you get there. And so x is equal to 1. We need to check this because we raised both sides to the 2/3 power. So that's something that could introduce an extraneous solution. So I'm going to go back to my original one and substitute in x equals 1. So I'm going to check x plus 3 to the 3/2, right? This was our original thing equals 8. We gotta put this in. So it's 1 plus 3. Did I copy this right?
Ari's thing also helps with this, because if you change 4 to the 2nd times,
Yes, you could do Ari's
Right,
method
to
too,
the-
or you could say this is the square root of 4 cubed, either way. Or you could do Ari's method.
It works now, right?
Works both ways. So x equals 1 is not extraneous. Okay, but the main idea here is if you want to undo something to a fractional power, raise both sides to the reciprocal power. Okay, questions? Okay, nice. All right, let's go on to the next page. All right, let's see what we have here. Okay,
did you multiply this whole thing by 3? No.
okay, so we've talked about this a little bit before. I'm recording this in case the people at the PSAT want to watch it. I need to get a different color. Okay, so the idea here is, this is called a rational equation because we have rational expressions on both sides. Okay, so in chapter P, we spent a lot of time simplifying rational expressions, and in those cases, we always multiply by funny forms of 1 because we didn't have an equation. But when we have an equation, the easiest thing to do is to multiply both sides of the equation by the least common denominator of all of the terms in the equation. That will clear all the fractions in one step, which is what we want, okay? So what is the least common denominator of all of our denominators? And this too has a denominator of 1.
X times 3x minus 1.
Good, so we're gonna multiply by the quantity x times the quantity 3x minus 1. And I'm going to multiply both sides of the equation by that. Okay, and I'm going to get rid of all the fractions. But I need to be careful because I may be introducing extraneous solutions when I multiply by these variables. Okay, so it's going to be times x.
You only multiply the numerators, right?
If you multiply, what do you mean multiply the number? You're going to try to get everything.
Yeah.
You could do that if you're gonna try to get a common denominator and then set the numerators equal. You could do that. I prefer to clear the fractions. Okay, so what happens now when I distribute this?
You get 7 times the quantity 3x minus 1.
Okay, so I'm gonna write this out the long way this time, just to make sure it's really clear what's happening, okay?
7x times 21.
So, and then this is minus, but Daniel, you're correct.
Is it okay if I write just 7x?
Yes, I would prefer that. I would prefer that you don't write all this out, but I know that sometimes I confuse people if I don't write everything out. So I'm gonna write it out this time, but I prefer that you don't, if it makes sense to you. And then on this side, the 3x minus 1's canceled. So now from this first term, the x's cancel. So now we're gonna get to what you guys wanna do. So it's 7 times 3x minus 1 minus 2x times 3x minus 1 is equal to 10x. The fractions are gone, right? So that makes this easier. Okay, so who wants to take it from here to help us finish it up? Okay, Logan, what should we do?
I think you should distribute.
Yep.
So you get 21x minus 7
Yep,
minus 6x plus 2x.
6x squared
6x squared. I'm
plus
sorry,
2x. Yep,
Squared plus 2x Should we keep the 10x on the other side, or
We should move it,
we should move it minus 10x equals 0?
yeah. Right, keep going, combine like terms,
So now we have 20, so negative 6x squared. to
Yeah.
Start. Give me 1 second.
Yeah.
I'm sorry, plus 13x.
good, plus
Plus
13,
13x.
Yep.
Minus 7 equals
Yep.
0.
good, I don't like this negative leading coefficient.
So you factor out the negative.
Yeah, so we can multiply both sides by -1 and we get,
Or that. So we just have 6x squared minus 13x plus 7.
How is it 13?
Yeah,
I'm
Yeah.
sorry, negative 13x.
No, it should be 9.
yeah, it should be 9.
9, I got.
21.
21 plus 2.
Oh, it's a
is
plus?
23,
No, that's a plus 2 minus 10,
Oh,
13, right?
okay.
yeah,
So it's 11.
I think that's right,
I
okay?
thought it was -2.
No, so it's-
Am I wrong?
I think you're right, yeah, I think you're right.
Yeah,
Good.
more what?
So now we have 6x squared minus 13x
Oh,
plus
my
7
God.
equals 0. I believe that's correct. How would you like this
AC
factors?
it.
So let's
AC
AC it. So,
Negative 6 and negative 7.
okay, so AC is equal to 42.
What? It's x minus 1 and 6x minus 7 is how factor the same thing.
Okay, so we need two things that multiply to
It's
42 and
negative
add
6
to
and negative
negative.
7.
Okay,
Wait,
negative
what?
6 and negative 7.
That's right?
Yeah. Okay, so we're gonna rewrite this as 6x squared minus 6x minus 7x plus 7. Right? And then factor by grouping, first two and second two. So what can we take out from the first two?
You can group it, you can factor out a 6x
Good, that leaves us with,
with x minus 1.
good, and from the second
You
two,
can factor out negative, a 7, right?
yeah, minus 7.
Minus 7, so that would be x minus 1.
Yeah, x minus
6x
1,
minus 7, and then x minus 1.
good. 6x minus 7 times x minus 1 equals 0. So now zero product property, we set each one of
So
these
you
to
can say,
0.
well, one of them is 1, I can do that. with
Yeah.
and then 6x, and then it's 7, 6.
So x equals 7, 6, or, oh, I wrote the wrong
7,
page,
6.
or 1,
No.
but
You have to put it in.
we need to check them. Okay, so I didn't leave myself much room. Let's go back up here. I guess I can squeeze the check in up here.
1 will be easier.
1 is easy.
1 works, the 1 works.
Okay, so let's do, I'm gonna do the
7
check.
over 7 minus 2 is 5.
Okay, so
And then
x equals
3
1, that works.
Minus 1 is 2, 10 divided by
7
2.
over 1 minus 2 is equal to 10 over 3 times 1 minus 1, which is
10 over
5.
2.
They're both 5.
They're both 5.
Okay, so x equals 1 checks,
Mhm.
and 7, 6. Wait,
Oh, God.
Well, you can
Okay.
just multiply it by 6, so the 7 over x will just be 6.
yes, so this is gonna be 7 over 7, 6,
Which
which
you
is gonna
multiply.
become 6.
So
Minus 2, I'll do that in the next step. 10 over 3 times 7, 6 is 21, 6 minus 1, right?
So that would become,
This side is 6 minus 2, which is 4.
But why is it 6?
Because you're gonna do 7 times 6 over 7. Because you're gonna
Oh.
flip the denominator.
and then 21 over 6 minus 1 is the same thing as
10 minus
15 over 6,
15 over 6.
which,
So this is 10 times 6 over 15. And then I can cancel out a 5.
18 thirds, which is 6.
2, 3.
I don't think that one works.
No, it does work.
Yeah.
Because then you get, when you get.
Wait, how did you?
Wait, did I do
1
something wrong?
times 16.
yeah, you get 12 over 3, so yeah, 4 equals 4. It works.
Oh, maybe.
12 over 3, which is 4.
Oh, yeah.
Great. Okay, so both check.
60 over 15 is.
Yep. 60 over 15 is 4.
Oh,
Good.
yeah.
So it's both.
Wait, is that last step? It's 4 is equal to 6.
4 is equal to 4, right? Because this
No.
is,
12.
we had
Sorry.
12 over 3, which is 4.
12 over.
Is
No,
it,
you guys
no,
are four.
is it
I did
10,
my math.
that last step, 4 is equal to 10 times 6 over what? I just can't read the number.
6 over 15, and then if you cross
Yeah, 6/15, and then I divide it out of 5. Sorry, I ran out of room. Okay, questions? It's okay, Ari?
I'm still confused at the end with how you were checking.
Okay, so let me write it over here. Okay, so we had 10/15/6. Is that where I lost you?
10/15/6.
So
Is
that
this
becomes
subtract
10/1.
6/6.
Yes, I subtracted 6/6.
All right.
Okay, and then I'm gonna take the reciprocal of 15/6, and that's gonna become 6/15. I'm gonna divide out a 5 from both 10 and 15. And then that becomes 12/3, which is 4, or you could divide the 6 by 3 and get 2. Okay, I lose anybody else? I apologize. Izzy?
Also, like my trick is, even if you're gonna multiply it like across, 10 times 6 is 60, 65 by 15.
Yeah, we could have just multiplied across here,
Because
because,
a quarter of an hour is 15 minutes.
yes, so this is 60 divided by 15, which is also 4. We didn't have to do all the extra simplifying it. Could have done, okay, yeah, nice. Okay, other questions? All right. So let's go on to absolute value. So we've been actually using absolute value when we've been taking the square roots and then we pulled variables out. But we're gonna study them a little bit more formally now, but briefly. Okay, so to solve an equation involving absolute value, remember that the expression inside the absolute value can be plus or minus, which means that every absolute value equation is really two equations in one, right? So we can set it equal to the positive value or the negative, right? So this can be, this is positive or negative. Okay, so in order to undo the absolute value, we simply write those two equations that are combined into the one nice absolute value. So Daniel, what would I do?
You would make 2 separate equations. One of them is x+1 = 2, and the other one is x+1 = -2.
Good. So the way I do it is I always just take the expression that's in the absolute value, write it out by itself. And then the right side, regardless of how complicated it is, I'll write one of them the positive value and one the opposite. Okay?
Wouldn't it be- Why isn't it why wouldn't it be like negative x plus?
You could. So you could do the negative on either side. Okay, so either I could take x+1 = 2 or the opposite of x+1 = 2. You could do this and this. That's equivalent to just putting the negative on the opposite side.
Oh,
Yeah,
right.
you can multiply by negative.
Yeah, so I find it easier because sometimes the stuff on the right side can get more complicated. I find it easier to just take the absolute value expression and write that just as it is, and then take the right side regardless of how complicated it is. Here it is not complicated. On one of the equation, I put the positive value, on the other one, I put the negative, but Izzy, what you said is equivalent.
And the rest of
Okay.
this column's really easy. It's just x = 1 and x
Yeah, now we subtract 1. So x = 1, subtract 1,
Could either one or negative.
yes.
And both of them work.
And both of them work, good. Right, because we're gonna check 1 + 1 = 2, and -3 + 1 is -2.
So when do we actually have to check those things?
You should always check with absolute value, because sometimes the technique that we're using, some of these may have the wrong sign. Okay, so this is easy to check. So both of these work. Okay. Right, it's easy to check. All right, this next one is more complicated, but the idea, the concept is the same, okay? So we need to write our two equations. Adi, you want to help us?
Yeah.
Okay, so what are our two equations?
So it'll be x minus 10 is equal to x squared minus 10x.
Good.
And minus 10 x squared, is it plus 10x? Or do you just?
So what I'm gonna do, just to make sure I don't make a mistake, I'm just gonna put the opposite, and then everything on the right side, I'm gonna put in parentheses. And then I'll distribute the
Well,
negative.
really, it's just x, it's negative x squared plus 10x.
Yes. The opposite of what we had before. Daniel,
Okay.
Doesn't x have to equal 1?
doesn't x have to equal 1? Well, 1 work. Yes, 1 is gonna be 1, well, 1 work. Let's see, I get 1 this side will be 9, and this side will be -9. So it's not actually gonna work, right?
But then how else will you have x minus 10?
Because it's a quadratic. So let's see what we get.
Okay.
Let's see what we got. Okay, so now we're gonna solve each
Yeah,
one of these.
So the
Okay,
first one, get everything to one side.
good.
So I have x squared.
Negative x
Minus
squared.
nine
Oh,
x.
no, no.
Well, we're gonna subtract x from both sides, right?
Minus nine x.
Would be
So-
11.
In the equation.
Sorry, 11x, x squared minus 11x.
So if I do that, so this side, one side's gonna be 0, is gonna be equal to x squared
Minus 11
minus 11x plus 10.
is equal to 0. And then that you could, do you want me to do the other one first?
No, let's do this one.
So
That's
then,
fine. So let's factor this.
It'll be -10 and -1.
Good. Great.
So, and that x is equal to 10 or 1.
Okay, Great.
And
So
then
those
this-
are possible values, and then let's do the other
So
side.
this one again, you'll want everything up to one side and then
Good.
you want to multiply by -1.
Or I'm gonna add
Oh, you
10x.
can
I'm gonna
just
bring that over, so I don't have to multiply by next one. So I'll add x squared and subtract 10x.
So you have x squared. Minus.
Yep,
Minus 10 is equal to 0.
good.
And then again, factoring it, get x, 10 and 1, so it'll be positive 10 plus 10.
Negative
minus
10.
The other way, because we're getting -9.
Oh, sorry, yeah, x, minus 10. And x plus 1.
Great.
X is equal to 10.
Okay, so we have 3 possible values. -1, 1, and 10.
We already know one doesn't work.
We know one that, well, we're gonna do the formal check, because we just did the informal check. Well, you're right. So now we're gonna check each one. So let's check x equals -1, x equals 1, and x equals 10. Okay, so -1, I have to remember the original expression. So the absolute value, I'm gonna rewrite it here. That's for x minus 10 is equal to,
X squared minus 10.
thank you, x squared minus 10. Okay, so let's put that in. So x equals -1. So we'll have the absolute value of -1 minus 10 is equal to -1 squared minus 10 times -1. So the absolute value of -11
So just
is 11. And this side is what? 1 plus 10, which is 11. So x equals -1 is good.
10 works as well,
Did 10 work? Okay, so let's do 10.
because 10 minus 10 is 0. 0 is 0 either way.
Okay, so let's put it in. Yeah,
And then 10 squared minus 10.
so this is 0 is equal to 0, check. Okay, and we know that x equals 1 doesn't work, but let's put it down formally. So x equals 1, we have the absolute value of 1 minus 10 is equal to 1 squared minus 10 times 1. Fill this up. So this gives us the absolute value of -9 is equal to 1 minus 10. So 9 is not equal to -9. So x equals 1. Extraneous. So our solutions were -1 and 10. So that's our final answer. -1 and 10. Okay, so absolute value, 2 equations in one. Simply write the 2 equations, then solve it. Might be linear, might be quadratic, might be some other type of equation. Everybody good?
yeah.
Yeah, okay, terrific. We're gonna start the 1.7 notes. We'll see how far we get. Okay, so these are linear inequalities, which I know you have studied before. So we're just reviewing them so that everybody is in
Will you be
place.
graphing? Ms. Chair?
Yeah.
Will we be graphing?
Will we be graphing the solutions for the inequalities? Yes, like on the number line? Yes, so we can write them as inequalities, intervals, and, yeah.
We're not gonna actually hit the graphing yet, like use the graph, like.
The plane?
Oh, graphing in the, yes, the Archimedes coordinate system, yes, that is coming up next, right after we finish this unit. We're gonna start graphing. Okay, all right.